So our next presenter, so this company I came across probably just about a year ago or a little less than a year ago, and just really love the technology that they've developed. And I really wanted to be able to share it with our audience, because I think we kind of micro focus on specific things. And this is not necessarily a traditional row crop that we've been talking about, but really worthwhile for you to understand where technology can go. So, company's Bloomfield, and our speaker today is Ben, and Ben is the business development director for Bloomfield, leading the company's sales and partner management activities. Over the past 2 years, Ben has developed relationships with Vineyard customers and partners across the United States, Europe, South America, and Canada. I know there's still something there's going in Vancouver or BC. Ben and the business development team continue to expand on Bloomfield's efforts to commercialize and expand on 10 years of research and development in artificial intelligence and robotics at Carnegie Mellon University in Pittsburgh, Pennsylvania. Prior to Bloomfield, Ben worked in business development for an early stage government technology startup selling software and artificial intelligence based analysis of city infrastructure and engineering firms and municipalities across the United States. So it's pretty interesting stuff as well. Over the past 8 years, Ben has pursued and worked at the intersection of social impact and technology. So without any further ado, I'd like to welcome Ben, and away we go.
Thanks very much, Andrew, for that introduction, and thank you very much for the invitation. It's great to be here. It's great to be with you all, and good morning. I'll pull up my my screen here, see if that works. So, as Andrew mentioned, we're here to talk about artificial intelligence in deep learning in agriculture, but I think the story is much bigger than that, and I'll hope to give you Bloomfield's story over the next 20-25 minutes, and I would love to answer any questions and have a discussion at the end. So please feel free to ask questions as they come up. Bloomfield is a young company. We're about 3 years old, but as Andrew mentioned, we have built off of a lot of research and development that has gone on for over 10 years at Carnegie Mellon University in Pittsburgh, Pennsylvania. That's where we're headquartered. That's where I am today. A little dreary, but that's sort of par for the course here in Pittsburgh. But obviously doing a lot of work around the country and around the world now, increasingly. And even as a small company, we're able to get out there. We have benefited a lot from that R&D I mentioned that was done at Carnegie Mellon by Dr. George Cantor, one of our co-founders, as well as Tim Mueller-Sim, one of our co-founders, and others. And it really provided us with a running start to the commercialization of the technology, not just from sort of nuts and bolts perspective or an engineering perspective, but also from a business development perspective, and that is more my world. And so you'll probably hear throughout the next 20 or 25 minutes that I have that I bring that angle to this conversation. We benefited from a lot of partners as well, and some of those partners were first established during the Carnegie Mellon University research and development years. So what does Bloomfield do? You saw on my first slide that every plant matters. So what we do is we use a custom camera to take pictures of plants at scale. Unlike drones or satellite and Unlike fixed, sensors, a fixed camera, our camera is attached to any vehicle that's already moving through the farm. I will focus a lot on vineyards today, through the vineyard, and it takes pictures of every single vine in that vineyard, and then with those pictures, we process them using deep learning techniques to look for key features in those pictures that determine the health and performance of those vines. And you'll see as I go through, these pictures are taken right next to the vine, sort of a perspective that really only a human being can get if they're standing there. It's in the fruit zone, so to speak. It's perpendicular to the plant. Sometimes our CEO likes to say, it's like boots on the ground, right there next to the plants. And the information that we can gather through those pictures, and also, of course, process with our deep learning, because of the deployment and the nature of those images, is unique. And we'll talk more about that as we go on. So our focus really is on being able to give actionable information to farmers on the health and performance of their plants. We focused a lot in vineyards, as I mentioned, but our technology, we believe, can apply across a lot of different crops. And so maybe that I kind of anticipate that will be the subject of some of the questions at the end of this presentation, but we'll get, when we get there, we'll cross that bridge when we get there. Some of the questions that we've set out to answer from the very earliest stages, and we still try and answer these questions every single day, is, how can Bloomfield help farmers? I mean, that's seems like a simple question, but unless you have answers to that question, probably in the wrong business. Is crop scouting and plant inspection important? And if it is, and how important is that activity? Our technology, as I've mentioned, is based off of pictures right next to the plant, and it's done at scale, and that activity can be thought of as inspection or scouting. So that's why we ask this question every single day. And then, does deep learning provide benefits to farmers, crop scouting and plant inspection activities, and does it create value? So those three questions are really at the top of our mind constantly. And I will circle back to these questions throughout the presentation. In short, crop scouting or inspection is just a formal way of describing sort of looking at a plant, as we all know. And there are different reasons to look at plants. But if, sort of in my simple mind, if you boil it all down, the reason to look at a plant is to determine how well it's growing. And you have to do that if you want to grow the best plants. There are a lot of sensors out there and a lot of methods for monitoring the different inputs to plants, whether it's irrigation or any sorts of inputs, sprays, weather. There are lots of sensors for determining what goes into a plant. There are very few methods to determine the impact that those inputs have on the plant. The methods available really are visual. It's really about checking to see how the plant is doing. I've mentioned, of course, satellites and drones, and those get the overhead perspective, which can be valuable. But we get the perspective that's right next to the plant. So that's one of our key kernels, our key focus points in this second question. How important is plant inspection and scouting? And then we dive into that with everyone we're talking to, whether it's a customer potential customer, partner, potential partner, etc. We ask them, that question, and we ask them to describe their scouting activities and the value that those bring to their operation. And with those answers, we can then start to answer question number 3. And deep learning and computer vision are methods that I'm here to talk about, so I will get much more into them. But it's methods to automatically train, algorithmic models to detect certain phenotypes, certain morphology, certain aspects of the pictures. And we train the models to do that, and then they do that automatically. And so depending on the answer to question number 1, question number 2 takes on a few different answers, a few different categories of answer. So you might be asking, just briefly, how we do it. And we attach this custom camera that we've developed and continue to develop. We call this camera the flash camera. Attach it to any vehicle that's already moving through a farm or a vineyard in this case. We have deployed, as you can see here, on 4-wheelers, ATVs, quads, but we've deployed on dozens of different vehicles: tractors, over-the-road tractors, big tractors, small tractors, semi-autonomous tractors. And maybe just as a quick aside on this point, we're active in Europe, in France in particular, where row spacing is much, much narrower. And the sorts of vehicles that they use in vineyards to do some of the work that they do are much different than here in the US, in large part due to that row spacing. And so we've deployed on all sorts of different types of vehicles that are common in France as well. And we continue to hold as a principle that we're going to be able to deploy on many different vehicles. So be versatile is one of the key aspects here. And circling back to some of the questions that I just went over, we really want to try as best as we possibly can to meet farmers right where they are. We want to be a part of their routine. We don't want to ask them to change what they do for us. So, for example, George Cantor, Tim Mueller-Sim, and others at Carnegie Mellon have built and developed robots. And one option might be, excuse me, one option might be to attach our camera to a robot. But robots have a tendency to be a little unpredictable. They have a tendency to be pretty expensive. And so trying to commercialize expensive, finicky robots is just not what we decided to do at this point. Sometimes I like to joke that robots might be a way to replace or supplement some labor, but you're probably going to have to hire a roboticist to keep it in the field. Now, none of that is to bash robots. They're certainly here and they're coming, and they're certainly going to be very, very valuable in agriculture. But what we've decided to do for the time being is to be versatile enough with our camera to attach to any vehicle and trying to meet the farmers right where they are and fit their routines. So once we capture those images, the idea is to turn every single aspect of the plant into digital information. And an easy way to think about that, of course, is in vineyards, every berry becomes a data point. But it's not crass. It's not just for data's sake. We have to be able to turn that information, that data, into usable information, into actionable information, into something that really matters for the vineyard manager or the winery or the viticulturalist. We have to be able to turn that information into action. And so what we've done here is be able to detect, count, and size clusters and berries first and foremost at different stages of the season, so that we can then offer a yield estimation all throughout the berry growth period of the season, and update that on a routine and regular basis. So the scans aren't simply one and done once a season. They are much more routine than that. Once a month, once every 2 weeks. And this is just briefly how it works. Obviously, you capture the images with our stereo cameras. One innovation around the camera is the active lighting that you see there, and another is the stereo lenses. The active lighting allows us to collect data, allows us to take pictures at any time of day or night. We're creating a bubble of light that really either drowns out the sun or overshadows any dark or overpowers any darkness. The stereo lens allows us to get depth perception in particular. So I mentioned sizing of berries and clusters. Sizing is a challenge for deep learning unless you have and having depth information in the images is a really great way to overcome some of the sizing challenges that are faced by image analysis. So we capture those pictures with our cameras, and we really think about that as sort of scaling the human vision, scaling the inspection, scaling scaling the scouting process. Excuse me. And then those images are pre-processed on the device to some extent, but mostly uploaded to the cloud, where a lot of the training and of course the model analysis takes place. So we are thinking about that as scaling that human expertise or that human perception. It's that knowledge that a human being would need to understand what they're looking at when they look at a plant. And of course, we have to be able to deal with a lot of data. A day's worth of data could be as much as 2 terabytes of data. And so for just one camera, we've got a lot of these things out there at this point, and that's a lot of data to be able to deal with. And so we have to be really clever about how we're both getting the data from the vineyard to the cloud, as well as how we're dealing with that data on the cloud and how we're storing it and how we're processing it. And then there's the analytics part, of course, which is the pointy end of what we do, and that is the most important portion of what we do. So I've mentioned, that we're in vineyards, and we think that our technology can translate to other crops. I've mentioned that we're analyzing a lot of berries and clusters, but it's really anything that's visually apparent on a plant. We can train the AI to analyze. So here in this image, you'll see just a few different examples. On the bottom right, there's a disease there, powdery mildew, I believe. The top left, that was a early customer that we were working with that halfway through the season was suffering from sunburn. And you'll see too in the bottom left that, of course, we're getting started with leaf analysis, which is very important, whether it's a vegetative growth index or whether it's looking at leaves for disease. We can do that as well. The image in the bottom left is actually an image of our labeling platform. Just quickly, when we start a new model from scratch, a good example would be a customer in France asked us to detect flavescence doré, which is a particularly difficult disease that presents itself on the leaves and shoots. It's difficult, for one, because it's difficult to distinguish between other diseases, and two, because if it is found, those vines need to be ripped out. It's actually law. And so we've started in on that, and that was a project that really kicked off at the end of this season, because the disease doesn't present itself very clearly until the end of a season usually. So we collect data in the field, and that data makes its way to the cloud, as I mentioned in the last slide. And the very first step we take is, of course, understanding the disease as best as we can, bringing in experts when we need to. Thankfully, we have a really great partner in France for this at the moment. And then human beings go through and they actually label every leaf on many images. By label, I mean, you can almost think of coloring on a coloring book. Now we have different labeling platforms that make that a lot more seamless, but that's the very first step. And then the models evolve. And as the models get trained, different tweaks are done. So that's the first step in any new model training, is the labeling. And that bottom image there is an example of a fairly recent effort for flavescence doré. And then we can present that data at any sort of resolution, any scale. So per vineyard, per block, per row, or even on a per vine basis. Oops, excuse me. So once the models are trained, well, let me say again that the models are trained really to look at patterns in the pixels, and that's how the models are then able to determine what the model's looking for. So we train it to say that these pixels represent a berry, for example, and with training, then the models can understand that those same pixels in an image it's never seen before, or pixels very similar to those in an image it's never seen before, represent a berry. There are different sorts of training methods. I'm sure we've all heard of things like supervised versus unsupervised. There are different sorts of labeling methods, and then there's different sorts of outputs that the models can produce. Here you see sort of a mix of all of those different things. You'll have bounding box labels that produce bounding box output. That's an example here in the sort of middle bottom, but then you'll have more semantic segmentation, which is the top right. Labeling, maybe a little bit more comprehensive, helps to get more precise sizing, for example. So there are different methods here, and I'm happy to give you the extent of my my knowledge if anyone has questions at the end. The real key here, I think maybe I glazed over and I'd like to repeat, is just that, we're training the models to look for things that human beings are already looking for, and then we're building on those. So here are some of the, again, circling back to those first three questions, how can we help? Is scouting important? And is deep learning part of could deep learning help solve some of the challenges? So here are some of the challenges that we've identified with yield management, yield estimation, scouting. And those challenges are at a high level, things like subjectivity, things like inconsistency. It can be time consuming and resource intensive. And then of course, number 5 there at the bottom is the small scale sampling that is often done to try and determine what's going on in the block and in the field. And sometimes because it's a small scale sample, that the information gathered can be misleading. So our technology and solution, I should say, and our insights are sort of offering benefits that, excuse me, that are directly in addressing some of those challenges. I'll start there at number 5 because I've just made a point of the small scale sample size when it comes to inspection or scouting. Scale is something that we can provide a lot of, and the benefits are clear to a lot of farmers. Our high level math here is that one camera in one day can do as much as one human scout almost in an entire season. We provide much more objective information, consistent, and like I mentioned, trying to meet the farmer right where they are, make it easy to use and convenient, and then of course comprehensive and precise. So with that, I'd like to sort of conclude here by saying, there are a lot of challenges when it comes to trying to combine custom hardware, artificial intelligence, and farming, but Bloomfield is using a unique combination of cameras that get right next to the plant for a perspective that until now has been fairly uncommon. And it's really in an effort to scale that human ability to evaluate the health and performance of a plant, evaluate the impacts of the inputs. And the way that we do that, and the leverage here, is deep learning. It is a way to be able to look at thousands and thousands of images very, very quickly and give us a lot of information about each one of those images, and then be able to present that information in a manner that's at any scale, per vine, per farm, and everything in between, and in a usable, actionable way. So with that, I will pause and love answer any questions you may have. Thank you.
Well, thanks a lot, Ben. Really appreciate it. It's great to see this technology being used, and congratulations on the development of this. I've been really impressed with the way this has come together. I think, I'm not sure if I heard you say this, but I think the other thing is important for people to understand is the speed in which you can gather this data. I think somewhere in the neighborhood of 20 miles an hour, you can go down a row. Is that correct?
We can go up to 30 miles an hour, but that seems a little unsafe in most agriculture environments. So we're usually in the 10 miles an hour range, but 30 miles an hour with no motion blur is possible. Yep.
Yeah. So when you think about that, how much crop, how much area can you cover? It changes the look, the dynamic of being able to scout and get really good information about your field or your crop and what kind of issues you're having. So we'll get to questions now, Ben. So we're going to start off with Kyle, and he asked, given that this technology relies on cloud pipeline edge processing, is rural, tough one, broadband access a challenge for adoption?
Yeah, good question for sure. There are a couple different questions packed into that one. So, true edge processing would be doing all of the compute on the camera itself. That would not necessarily rely on connectivity in rural areas. That is not, we're not there yet, although we're pursuing that. In fact, we have a NASA grant, which I haven't mentioned, but we have a NASA grant to pursue. A big part of that is pursuing our edge processing capabilities. But you're absolutely right when it comes to the challenge of rural connectivity in some areas. And so, because right now we have to get the data from the field and the farm to Amazon Web Services. And that takes on a lot of different forms. One is sending hard drives. If it's truly no connectivity, then we need to be able to send a hard drive to a place where there is connectivity so that we can upload that data to Amazon Web Services. Thankfully, most areas have some connectivity. And so we often, we will install a server in their IT room, and we'll make the best use of that. In short, we believe moving to the edge fully will help overcome some of these issues. We also realize that there are different methods that we need to be able to deploy to overcome some of the challenges that we face now with the connectivity issue.
That's great. So I think we're seeing this with other with drone capabilities, data stuff, where they're doing that edge technology. So I think we're going to see it become more commonplace, Kyle, as things come along. So I think that's really encouraging for when you do have that broadband issues, that rural broadband issue. Question from Cassidy. Do you have any figures comparing the accuracy of the automated detection of specific issues versus human identified issues? Which I think is a great question. And I think you got some good data on that as well.
Yeah, so the way I hear that question is, we're focused a lot on yield estimation and yield management activities and informing those. And so yield estimation is a pretty, well-defined metric to measure ourselves against. We provide a yield estimation on, let's just hypothetically, July 1st, July 15th, August 1st, August 15th, and we update it, and then and September 1st, and then harvest it takes place, and everything is measured for real. Weights are in, counts are in, boxes, whatever the case may be. We're in wine grapes and table grapes, and so they measure things slightly differently. So in that case, with yield estimation, our goal really is to be, at this stage, is to be within 10% error, so 90% accurate. And the vast majority of the time we are. We have had instances where we're not that accurate, and I can give you a long list of our hypotheses as to why. But that really is our goal. Now, our goal moving forward is to get even better than that, of course, to get down to 7.5% error rates, or 5%, or sub 5%. And we believe that's achievable. And I think, again, there are different techniques that we need to continue to develop to become even more accurate.
Yeah, so I think just kind of a follow-up on Cassidy's question. I think when you think about human scouting, when you're walking down a row and trying to say, okay, is this an issue or is it not an issue? What can I see? What can't I see? You have technology that identifies some of this stuff automatically. Some of it is even stuff that you're not even going to notice by the naked eye. What kind of and then obviously your speed makes a big difference, because rather than scouting, a small area by human purposes, that takes a long time. You're doing it, at 10 miles an hour and getting all that data. So when you show those two figures of human scouting versus your scouting, where's the difference there, and what kind of savings are you seeing because of being able to identify issues?
Yeah, good follow-up, challenging to answer. So I appreciate challenging questions. It's the thoughts, flowing. But I think there are a lot of different pests and disease, for example, a lot of different things that present visually, nutrient deficiencies, for example. And we're certainly not doing many of them at the moment. But we believe we'll always have more to do, and we believe we can do those quickly. It's about finding the answer to your question. It's about finding what's most valuable and what can we do best. And one of the aspects, of course, of scouting is being able to detect something. Another aspect is detect it when. Is it early enough, or does it need to be early enough? The third aspect of it is quantification. I've seen it, I've detected it at the right time. How do I measure it? How do I describe it? Yeah. And so those three things are huge. And not all, in my limited experiences, not all pests and disease have the same answers to those three. So for example,
absolutely,
on the quantification of something, sometimes there are industry standards. There's an industry standard for hail damage in Italy, for example. There's no industry standard necessarily for sunburn in Oregon. So quantifying it becomes a question of working with our partners sometimes, and or with our advisors to determine how to quantify it and how, produce a standard, not the standard, but a standard that makes sense to the grower. Detection, not always important to know that you have, I hope I don't misstate this, so don't take this as gospel by any means, but not always important to know very early that you have red blotch or maybe leaf roll. But it's important to know that you have it if it reaches a certain, if it's overtaking everything. It's useful to know where it is. So sometimes the timing of detection is not crucial. Sometimes it's very crucial. So it's a long, that's a very long answer to say, we can be very accurate on things like that present themselves visually. They're clear, like a sunburn, for example. Less accurate on when things are occluded. They're on a leaf, behind a leaf, and they don't show themselves, and they need to be detected very early.
Yeah, that's great. Brandon, you would think that the average person walking down a row would not be able to necessarily see that if it's behind a leaf as well. So I don't think it puts anything negative towards your software and your cameras. I think you're still doing so much more and so much faster at a lot less human costs than anything else out there. So I think it's still fantastic. Big question for Bonnie, and I think you and I have had this conversation before, but has this been tried on other crops?
It has. So we are working in Peru with a blueberry grower, a very large blueberry grower. And we have tried it, of course, well, maybe not of course, but we've tried it in apple orchards, as well as cherries, even on hops. And increasingly there are, our partners or our even our advisors are starting to give us, ideas about this crop would be good, this crop would be good. We have done sorghum in the past. So yes, we've tried it on other crops. And I think we're very interested on being able to translate the technology to other crops. And some crops, and that matrix, that translation matrix, if you want to call it that, how that might work, is not overly complicated. It's about identifying the operational aspects of a different crop and identifying how some of our AI would translate, or where we could start again, and the value. That's really the crucial one, is what kinds of problems are they experiencing in that crop? Is our technology suited to help try and solve those problems or tackle those challenges?
Yeah, absolutely. And I think you've got the right formula. It's all about getting the learning part down, and I can see this being used in a lot of different places. I am a little curious on how you did that with hops, knowing the way that I know hops is grown on big gigantic poles that are 15 feet high. How are you doing that on hops? Do you have to be a certain distance away, or how does that work?
So in that case, it was about stacking cameras on top of each other. And that was actually the specific reason we did that, is because we wanted to experiment with that sort of stacking. And that's a method that we may have to deploy in the future as well for other crops. Sort of in my layman's terms, the terms that make sense to me, because I'm not the hardware guru by any stretch of the imagination, but just to increase the field of view, basically. But there are other methods potentially that we could develop. You could have one camera that's set at different heights as you travel through. You could have a really consistent height across everything, and maybe accept the fact that you're sampling only half of the plant. We don't want to settle for that. That's why we want to be able to stack. But a good question.
All right, so I think we're getting close to our time. So one last question, real quick. Any spectrums that can help lead to optimal harvest timing as far as the sugar, the acid ratios in the grapes?
So for now, we've stuck with just the RGB, the visual spectrum, which does not allow you to see into a plant or get any kind of signatures from those waves that might help determine what's inside the plant. The reason we've done that, just briefly, is because we really want to stick to this idea of being inexpensive and easy to use. We don't want to add sensors for sensors' sake. We believe with RGB, we can really get a lot of really valuable information. That being said, we are experimenting with hyperspectral as part of this NASA grant. But in the context of harvest timing in particular, even just a color analysis can be useful in table grapes and probably other crops. And that color analysis, as part of veraison, which is not the bricks content and not that kind of thing, but it is a part of veraison, can be a helpful tool for table grape growers, because they will often harvest across a month or even more in the same block differentially, and they'll want to know where their more ripe clusters are at any given time. And some of the ripeness will depend on that color. So short answer is we're not using anything beyond RGB. We're getting a lot of great information with RGB. Part of the reason we don't want to move away from that right now is we don't want to make things radically more complex or expensive. And we can already provide a little bit of information around harvest timing with RGB. And we think we can probably provide more moving forward as we develop the correlations between what is visible with RGB and what's happening in, sort of quote unquote, on the inside of a plant.
That's great. Ben, really appreciate it. We've run out of time, but really appreciate your time. And for anyone who is still on, it looks like we still got a bunch. Ben did say that they're going to have some interesting news coming out early next month. So stick around, keep watching Farms.com. We'll make sure that we share that with you as well. So thanks everybody for joining us, and looking forward to you for our next presentation, Chuck from Haggerty Creek. Thanks, Ben.
Thanks so much, Andrew. Thanks, everybody.